Okay, doke. All right, let's go ahead and get started with the news of the week. There seemed to be a theme when I was looking through all of the news articles, and it's kind of just reiterating or emphasizing some of the stuff we've touched on before. Enphase acquired a company called Clipper Creek, which is a EV charging company. So it feels to me anyway, like a lot of these inverter companies are starting to look towards how to integrate charging systems, into their inverters so that you can start to have the vehicle to grid and vehicle to home structure, so that they're going to go with their own product line on that. This company called Lumen Edge, they announced a smart circuit app, and in looking through all of their marketing material, basically what they were saying is, we've finally addressed the whole issue of there's never any space in your service panel for all of these smart circuits. This gets back to that monitoring your consumption, being able to turn it on and off appliances through a phone app. And their approach is, they've got this little hub that hooks into your wireless, into your Wi-Fi system. And then they just simply claimed that the homeowner can easily attach these little modules to whatever circuits or to whatever appliances that they want to control. And in their marketing, it was saying no need for an electrician, the homeowner can do it themselves. So I was thinking it must be something that clamps onto the wire, like an amp, one of those amp things. But when I looked at their installation videos and their marketing material, it doesn't look that way. And I could see that you could monitor it that way, but you couldn't turn on and off the appliances if you're just putting an amp ring on it. So it does look like it's a little tiny thing that you cut the wire and attach this unit to. Well, that seems outside the scope of most homeowners, especially since at the circuit level, most of those wires are going to be hidden, so in the wall or whatever. So it struck me a little bit like that old Steve Martin routine about you can be a millionaire and not pay taxes. Where he goes, first make $1 million, then don't pay your taxes. It's like, this is so simple. You just, rewire your house. So it struck me as not really the panacea they were throwing out.
Are you familiar with, there's a couple others like Emporia, and I think, what's the other one here? EF. Is it like those? I think those are similar to what you're saying.
My guess is there are a lot of them where you talk about at the appliance level. There are some like at their smart circuits, but those tended to be a replacement of a circuit breaker. And the breakers then had a unit in there that coordinated with your Wi-Fi system. Problem with those is they required extra slots in your circuit breaker box.
Okay.
So if it was a single pole breaker, now it was a double pole breaker because one of the breaker poles was communication. And not many people have that kind of space available in their service panel box. So I think the easiest one would be one that just attaches to a plug. If for a homeowner, I would think you plug it in, then you plug the appliance into it. And that seems like something that doesn't require you cutting the wire and making an attachment. But I haven't seen any specifically like that. I'm sure they exist.
Okay. The Emporia one I was looking at, and I haven't put it in or anything, but it looks like it's got these little things that hook on inside the circuit breaker box onto the wires, not to turn them on or off, obviously, but just, I think, to tell you if there's amperage running through them.
Yeah, I know they've got a lot of those things. What are they called? CTs that you can put over the wires, and they will monitor amperage flow through the system. And that's pretty easy. But I think what they're really hoping to get to is with your phone, you can turn on and off appliances. You can schedule them. You can put timers on them. You can, did I forget to turn off my stove? Okay, I can do that while I'm sitting at, the opera, I'm sure, which is where everybody is.
it seems like you could you could do that with like a plug-in, like the old timers they used to have when you went away for the weekend. You know, like click, 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 and then it would turn on or off the switch at
Yeah.
the plug level. But you're saying they think they can do that for the whole circuit?
Yeah, there are, we had touched on it.
Okay.
There are actual like Siemens company and some of those guys are making
Mhm.
whole new service panels
Okay.
that will control it. But then other companies like Eaton are making controllable breakers so that
Mhm.
you can do that. And then there's a whole nother level where you can say, okay, now we're just going to go to the appliance level. We're not going to talk about the entire circuit.
Okay.
And those are kind of like this one where you get a centralized control unit that speaks
Mhm.
to the Wi-Fi that you can access in through your smartphone. And then you can turn on and off or set timers on and off and that kind of thing
Okay.
remotely off your phone. So it's a general movement towards load control, controlling the
Mhm.
loads at the residential and commercial level, which is a big change for our,
Mhm.
for our lifestyle. I think it also then throws in a whole new level of cybersecurity because
Yeah.
if you can control it, other people can control it as well. And
The
there's,
Chinese.
yeah, well, we've seen that where supposedly the Chinese were messing with the Florida grid, just
Yeah.
to show that they could. Teenagers, some teenage hacker could do it. What
War
about,
Games 2020.
yeah, well, what about places like, critical loads? Critical loads, like I could threaten a hospital, turn off all of their
Yeah.
intensive care unit, or banks, I could turn off their whatever. And then there's
Mhm.
the other issue of, I know that the data breach for Target,
Mhm.
where they lost like 1 million numbers, credit card numbers, that happened through a smart thermostat. So if you
Okay.
can get into your system through an appliance,
Mhm.
are all the firewalls in place because everything's connected together and you can begin,
Mhm.
smart hackers are going to figure out a way to steal your stuff. So
Isn't this also what they complain or not complain about? They say could be a threat with either the not the remote control, but the autonomous vehicles and or just electronic, Teslas. If they have connections to the grid and they're all electronic controlled, they're fly by wire. They're not like actual steering connected. It's all electronic.
yeah.
Isn't that the suggestion that people could do that too if they wanted to?
Yeah, there are a lot of issues. Anything that's connected to the grid, you've got not only security issues where somebody could take control. For instance, if I could take control of an autonomous vehicle and make it start driving 100 miles an hour or something remotely,
Mhm.
that would be dangerous. But somebody could hack in for security, for privacy issues. And let's
Mhm.
say there's an abusive relationship going on and somebody wants to know where people are. Well, they can track them on their phones, but they can also track the vehicle, and who owns that data. That's always an issue. What appliances are you running? When
Yeah.
are you running them? Is that of value to people? Who knows? You could tell thieves when they
Mhm.
could break into your house. There's a whole bunch of stuff that
Yeah.
could be monitored through this. And I don't think that our electricians and our utilities are prepared to be cyber warriors, even though they're beginning to create the infrastructure that requires that kind of expertise. They don't have it. And there's going to be some problems. But it's also kind of cool, some of the things you can do. So who knows? We'll see where that goes. Another thing is a new company, the floating solar. We've touched on floating solar. That seems to really be a thing all of a sudden. I was always thinking that was maybe just a little sideline, but as we'll see in the code changes, they're starting to put in codes for floating solar. There's a new company, subsidiary of SunGrow, called US Floating Solar, which is a pretty good name. So there are issues there about the floating platforms themselves, cable protection, and anchoring within the pool of water. And I could really see a need for this kind of thing, or a desire for it. I know when we were doing commercial property down in Florida, every single commercial property had to have its own, water retention system for on-site water maintenance. And, if you're going to have these little shallow retaining ponds, why not use them as an energy source, area? For the most part, they're pretty useless. They're not deep enough for boating or fishing or whatever, but you got to have them. So that might be an interesting application. Also, a lot of reservoir, area is available near population centers. So that's a thing. Solar shingles have raised their ugly head again. Suntegra company is looking at expanding their solar shingle production in New York. And these shingles are apparently about 114 watts each. So it's a thing. I'm not as sold on solar shingles. I think it creates a lot more problems than it solves, but I'm sure there are applications for it. The U.S. Department of Commerce rejected the tariff claim on Malaysia, Thailand, and Vietnam solar panels. So I had mentioned that a couple of weeks ago, where they were some anonymous applicants. So 3 guesses who they were, no doubt, American-based solar manufacturers, were trying to then establish tariffs on not only panels coming from China, but also from Malaysia, Thailand, and Vietnam. Those failed. So that's good. Good in my opinion anyway. Another thing that sort of plays on something we found last week, you remember I said ADT ended up acquiring a solar install company, SunPro? Well, this week Brinks announced that they're in partnership now with Sunnova. So apparently security systems and solar are suddenly a thing. So I don't know, it may get into the whole smart home thing, where you're talking about monitoring all of your electrical on a circuit-wide basis. Well, it seems to me a residential or commercial security team might want to be involved in that. It might have to do with carbon credits, how to measure and coordinate those. So, but it's clearly another development that's beginning to happen, where home security people are getting into solar. So where that leads, we'll find out. And the other piece of information I saw that I thought was interesting is a Mississippi utility, the company called Entergy Mississippi, has announced they're going to put in 1,000 megawatts of solar in the next 5 years, which is not a small amount. And of course, Mississippi has not really been the hotbed of solar development up till now. They're replacing natural gas plants, which is interesting. And that is going to increase their portfolio from 1% renewable to 32% renewable. So they're going to be about 1/3 solar primarily, which I think is an indication of what utilities are striving for, no doubt. And I know we've touched on it before. What is the sweet spot where solar and wind can service the grid without storage? I've seen articles that have said 30% is about the place where the variability of solar is okay with existing systems. I've seen it pushed up to 50%. So not sure, but once we have storage in large measure, then Katie barred the door. But if any of you guys look at the Guardian newspaper, it's a British newspaper. They have an interesting thing on their online page. Every single day it talks about what percentage of the UK grid is coming from renewables for that particular day. And I've seen some days where it's up to 70–80%, which is pretty amazing. Although they do incorporate nuclear into that renewable portfolio, which, I guess technically it is, but, it has its own little set of problems. So, all right, that is the news that I saw for the last week. Anybody have any comments or anything to add to that? Yeah,
Just a
Jay?
question, the water-based ones in Florida that you're describing, do they have to be on some tether? Because a lot of times a detention pond is dry. So they have to be able to sit down on the land and then float, or are they always suspended in water?
I don't know. I suspect it depends on the system, but I would imagine they could, if they can sit on water, you would think, unless the bottom of the pond is real irregular, that would be an issue. If it's flat, I would think it wouldn't make much of a difference, but I don't know. I don't know enough about it. Yeah, Bob?
Looking at electric cars or any car to be autonomous in driving in the United States, the whole idea of developing an automobile that can detect everything, I think has failed totally. And in my mind, for many years now, I said the only way you're going to do that is by mapping out all of the streets and maps of the United States to nth degree, so that you then command the car not to go off cliffs and like that, and to have communication. And that's what Tesla has announced this last week, that they have come up with the mega computer that's going to do this. That,
Bob, don't they also have to see like where people are or other cars or, other obstacles?
well, they don't count, come on.
I think there's a lot of challenges, obviously, in having an autonomous vehicle. I did see one where Tesla ran into the side of a semi truck because it had a picture of a horizon painted on the semi truck, and the car read that as open space, as opposed to a vehicle. But it's like a new technology. I would tend to agree, Bob, that in my mind, my initial blush is these things seem beyond our current technology. But then I watch other people driving on the road and I think it can't be worse. These guys don't know what they're doing. So maybe, who knows?
They said that texting and driving is as bad as drinking and driving.
Yeah.
I actually saw a guy drink and text and drive. He was on the wrong side of the road.
Yep. Yeah, it'll be interesting to see how it progresses. We're still in the early stages of it. My car that I drive has the ability to tell if somebody's slowing down in front of me and applies the brakes if they slow down. So that's a little thing. It's a step in that direction. I don't think I'd trust a vehicle to just drive. Of course, I don't trust my wife to just drive, so I have to, be in control. So that's my own issue. But
you can call a Tesla from a parking lot to your front of your door now.
Yeah.
Like the dog?
Come on, boy. Yeah, I don't, I just think there's got to be some issues there. There's got to be some growing pains that may stop it dead. If all of a sudden there's a malfunction in a server somewhere that's controlling all these, and you have 50 or 100 or 1,000 crashes in one day, that's like having a nuclear meltdown. It's going to really, really destroy the technology, set it back quite a long way. So even if it's technologically possible, politically it probably wouldn't be possible. All right. Any other comments?
Yeah, Jay, did you see? There was an article in the Wall Street Journal. I think it was over the weekend. That did essentially what you did in your podcast a couple weeks ago, where they compared driving, an electric car versus a gas powered car, but instead of just in general, they did it in like 10 different cities. So they compared the average cost of charging, at home versus on the road. And then that compared to the gas prices, the average gas prices in those cities. And I don't know if you'd seen it because you were talking about it the other day.
No, I didn't see that one. What was their conclusion? They didn't like electric cars?
No, it was essentially the same as yours. It's if you only drive around your house and you charge up at home at night, that it's economical. If you're going to if you're going to drive a long distance or charge up, I don't know, in the cities or where, public charging is what they kind of refer to it as.
Yeah.
Then there's a tipping point, and after a certain point, it becomes uneconomical, or it just not uneconomical, but it becomes more costly for fueling up using the electric.
Yeah, I think some of those charging stations are charging quite a premium, so that of course will change as there's more access to those level 3 charging stations. But yeah, if I invested $150,000 in a level 3 charging station, I wouldn't want to recover my money. That's a big investment.
I have a friend who has electric vehicle, and they have a charging station where he works.
Yep.
And that's part of a corporate benefit that you can, so he doesn't charge at home at all.
Yeah, it's like getting free pencils and paper clips at the office, you just
But they plan on giving it to you for this one.
Yeah, that's true. Well, we just taught a class down at MeLink in Cincinnati, and their facility has solar canopies in all the parking lots with charging stations at almost every single parking spot. Those are level 2 charging stations, so they're charging at 240 volts, not high voltage DC. So I think we'll see that happening a lot. Walmart's putting them in, AMC theaters putting them in. It's a way of bringing people in, keeping them up on site. They'll give you free electricity if you stay in and buy their crap. So that's all right. Well, let me jump into the 2023 National Electrical Code. Right now, of course, we're living with the 2020 code. The way these things work is the 2023 code will actually come out in July of 2022. So the first draft of the code was revealed in January, the committee met in January. The draft was posted in July 2021. They then went through a review process on what was drafted. And now they're in the second draft phase, which will be released in March of 2022. Then there's an appeal process. People can argue, I don't like that or whatever. And but then the final draft will be July 2022. So I was looking through some articles as to what constitute the big changes. So focusing first on solar, because that's what we're talking about. We've talked about before where a lot of the webinars have talked that batteries are going to have to be outdoors for your facilities. I didn't find any reference to that in the articles I saw, and I didn't actually read the entire draft, which would drive my eyes crazy, but I'm going to assume that's still the case, which that will be a big change for our industry, is making sure all new batteries are for systems are outdoors. Let's see, a lot of labeling requirement changes. It strikes me when I read these articles that it's mostly people doing wordsmithing. We should remove the word this from this label, or we should change that. There is a new label for floating PV, which is, I thought, interesting. They're putting in a new article, Article 231, which are for electric power sources interconnected with the electric utility. So what they're doing is essentially AC and DC coupled systems will fall into this new area. So the NEC is clearly thinking that there are going to be a lot of systems that interact with the grid, but when the grid goes down, they become autonomous systems. That's really what's going to fall into this. And there are going to be all of the rules and requirements there. Normally, when they add a new article like this, it's pretty Spartan. They just take things from other parts of the code and put it in there. But it's an indication they think this is going to be an area of rapid change, and they want to give it its own identity. There's another movement where they've got Article 245, overcurrent protection for systems rated over 1,000 volts AC and 1,500 volts DC. So, and then there's another article, Article 305, a new article, wiring, requirements for wiring for systems over 1,000 volts AC, 1,500 volts DC. So what the NEC is doing here, according to the analysis that I read, is essentially putting a stake in what they refer to as medium voltage, the higher voltage systems. Apparently, when you get into really high voltage systems, that's usually covered in the NESC, the National Electrical Safety Code, and that's what utilities follow for the most part. The NEC has usually kept themselves at 600 volts or less, or 1,000 volts or less. Now they're starting to get up into bigger systems. And we know in solar that our solar systems are getting more and more higher voltage. So I think they're beginning to acknowledge that. We'll see how that works. They are deleting Article 720, which was the batteries under 50 volt section, and folding it into Article 706, which was the new stationary energy systems that they added, I think, in the last round or maybe in 2017. So essentially, they're saying batteries are going to start being higher voltage. We already see that, but they stated that there was some confusion in that people thought the 50 volt and under applications applied to all battery systems when they didn't. So they're just getting rid of that chapter, and then they're just going to have only one chapter dealing with stationary battery systems. So we'll see where that develops. Those were the only major things I saw as far as solar. So it looks like a pretty light period for solar changes, few labeling changes, the batteries going outdoors, and starting to deal with higher voltage systems. But in electric in general, they're putting in a whole thing on cybersecurity in the National Electrical Code. So clearly they're recognizing some of the issues around, you know, the interconnectedness of electrical systems. They're putting in a bunch about arc flash for systems over 1,000 amps. So they're starting to recognize some of these higher amperage systems. And there were a lot of talk about enclosures, basically requiring that a lot of this electrical equipment be essentially under lock and key. You know, and there was things about feeder tap barriers. Anything 1,600 amps or greater had to be in its own enclosure. Switch enclosures that require a special tool to get into, and can only be accessed by people with training and authority to get into. How they monitor that, who knows? But hopefully it'll be like, not like the MC4 connectors where they say a special tool is required to open those, and which is my fingernails in most cases, you know, the special tool required. And then the big one, which is going to affect all of us, is starting with the next code, GFCI outlets are going to be required on all outlets in the home. So no more regular old duplex outlets. Now you're going to be spending $20 for every outlet that you put in, or 25. So no more just around water. It's going to be everything you put in. Yeah, Chris?
I thought that when you put one GFCI, it took care of the whole circuit.
Not really. It depends on, I guess, where in the circuit it is. But I think what you'll probably see is if they're requiring GFCI on everything, why not just put in GFCI circuit breakers?
Yeah,
You know, and get it all taken care of at the source,
yeah.
which, you know, and so I would guess we're going to start seeing service panel boxes that just automatically assume that it's going to be GFCI, you know, ready, however that works. So those were the major changes I saw in the National Electrical Code. Anybody have any comments on any of those? Okay, anybody have anything else for the good of the cause? Yeah, Jay? You're muted, Jay. Jay, you're still muted.
May not be for good of a cause because I'm maybe the only one that doesn't know it, but if I'm right, that recollecting that brownouts will sometimes pull the 60 cycles down to 59 point something or other. Who controls that cycling, and how is cycling synchronized across multiple systems of big utilities, and how does that work when you've got lots of little pieces?
Yeah.
Get them synchronized.
Yeah, you're just talking about frequency circuit, you know, the hertz, not the amps and volts, huh? I don't know. Before I comment, does anybody have anything they want to answer that? Any of our electricians? I know within solar, your inverter has to get that waveform synchronized before it will connect up to the grid. So it's supposed to be in harmony with that. But you do get transients, and you do get, you know, issues that do mess with the frequency, cause frequency distortion on the grid. And that's a big issue as far as utilities are concerned. So that was part of what California Rule 21 with inverters was designed to clean some of that up as it ran through the system. But my understanding is the only way of really cleaning it, and what some utilities will do, is run everything through a battery bank. You know, basically take their AC signal, convert it to DC, flow it through the batteries, and then re-invert it to AC, so you've got a clean signal on the outside. I know an installer who actually did a system like that for a city in Ohio. And AEP, the reason it was financially viable is AEP was paying the city to run their power through it to clean the waveforms. So they were basically running it through a DC scrubber. So I'm sure there are other electronic devices you could hook up, but on a utility scale, I think it can be problematic. Bob, you had a question?
No. When you're on a grid hookup solar system, to match your AC, the only way I could come up with is you have to attach it to the grid. And
Yeah.
on the end phases systems, it's not working until you attach it to the grid.
Right.
And then that AC curve is goes all the way up to the inverters on the roof and everything.
Yeah, I think solar is not such a big problem, but I think there are other external factors that can mess with the frequency on the power grid. You know, lightning strikes come to mind, you know, that there are constant impacts to the quality of your power. And if you put a meter on it, you'll see that it does fluctuate not only in voltage, but also in hertz. But that hertz fluctuation is usually, you know, 59.9, 60, 60.1. I don't think it fluctuates that much. But Bill, you had something to add?
Yeah, I assume you're just talking about the quality of the waveform out of a solar inverter. Is that correct?
What's that?
It's time to go.
No.
What was that, Bill?
You're talking about the quality of the waveform out of a solar inverter. Is that correct?
I think, Jay, you were kind of not just stuck with solar, you were talking about the waveform in general on the grid?
Yeah, just an intrigue with even big systems merging their power together.
Yeah, yeah, and it is an issue. In fact, I know that when they transfer them, that's one of the reasons why the high-speed transmission lines are DC. In, those big lines that are going out west and everything, because when you're moving between one system and another, it's a lot easier to take everything to DC and then convert it on the other end. That way you're able to assume that the waveforms and everything are compatible with your own system. I would guess not only lightning strikes, but resistance, would probably mess with not only the voltage, but it might have some impact on the waveform as well, traveling long distances. So I do know they do a lot of conversion to DC and then back to AC to
Yeah,
clean
that
up the power.
implies separating normally a solar farm or wind farm puts power on the grid at line voltage, high voltage, right?
Yeah,
But by using high voltage DC transmission, you've got to have an inverter on the other end, and that complicates things. But I won't go there. But I will ask a friend of mine with an oscilloscope. We'll look at an AC waveform and see whether there's any way of qualifying the quality of the waveform. That'd be a good project. And I'll do that and try to report on that next time.
okay. Yeah, I know dirty power is always an issue, and that's one of the complaints utilities have had. When you have multiple sources of power coming onto the grid, there is that potential of these sources causing harmonic distortion out on the grid. Now, the UL 1741 SA standard for inverters is supposed to avoid that, but not everything always works, according to standard, or is installed using standard-based equipment. So I think it's a legitimate concern, but usually when you hook these things up, they're supposed to synchronize. And I think there's a natural process where things tend to synchronize when they're connected as well. Is that not the case? I know with wind turbines, there are some that take their power signature from hooking up to the grid. So it's the act of hooking up to the grid actually establishes, through almost like a gravity kind of thing, the waveform and the voltage and everything else. I know, Gabe, you're nodding your head. Am I talking out of my hat?
No,
What is this, that hat?
I think that's right. It works that way too. If you hook two generators together, they'll speed up or slow down to match each other's harmonics, and so they're each other's wavelengths. So yeah, that's exactly how I understand that works. Yeah.
All right.
Well, I do know that with Enphase, when on a hookup, you first have to get Edison hooked up before you can hook up Enphase's connections and stuff.
Yeah, that's true, because of course they have the anti-islanding provision within the inverter. So until they see the signal of the grid, they will not generate, which is a downside with Enphase, because you can't really be assured your system is properly installed until everything's activated. But with Solar Edge, that's one of the reasons they had a 1 volt signal voltage from the optimizers, because prior to the grid hooking up, if you're running 36 power optimizers, you should be able at the point of connection to test it. And if it's 36 volts, all 36 of your inverters your optimizers are connected properly and broadcasting. Then once they see the grid signal, they'll function at their full capacity, but they just send a 1 volt signal volt. And that's just for testing it during installation.
And you have to wait, because when I hooked it all up and turned everything on, it didn't function right off the bat.
Are you talking Enphase or Solar Edge?
Enphase.
Yeah, Enphase, yeah, there's a 5-minute handshake typically where it takes at least 5 minutes. I've seen it sometimes take 15 minutes or more. And not all of them come on at the same time, you know, you'll start seeing this one come on and then that one, and you keep looking at the little lights and is it green, is it not, you know? I don't know, have you looked at the 7s? Do they even have little LED indicator lights anymore? The IQ 7s?
On the inverters,
Yeah, on the microinverters.
I saw a bulb, but I couldn't climb underneath the panels to see if they were on.
Okay, yeah, I think it is on the side, if I remember right. Yeah, and they're kind of hard to see. And the difference between the red, which is an indication that it's not seeing the grid, and the orange, which is an indication that it is seeing the grid, but it's not communicating properly. I can't tell the difference when I look at them. They all look the same to me, so.
But the important question is, did Bill clean his battery contacts or not?
Oh, yeah. Hey, Bill, did you find out why you were getting so much voltage irregularity there?
No, I did not, but the system works. They're balanced since I connected the midpoints now. And I'll ask my smart friend about that. No, that was an interesting exercise. I found it interesting that it balanced all the batteries, in the series connection.
Mm-hmm.
By the way, Gabe, you said you've got a 48-volt system with 6-volt batteries. Did you look at the voltages?
Yeah, I didn't get a chance to do that chore this weekend. I adjusted my panels for winter, but I didn't test the voltages. Hey, switching the subject a little bit, Jay, you had mentioned earlier that another company has gotten into solar shingles.
Yeah.
We got a question last night about solar shingles, and I was thinking purely about Tesla. And the last information I can find is that they've installed, it's dated 2020, but they've installed less than 100 solar roofs using shingles. Do you know if that's changing at all? Has there been something in the last year where solar shingles has really changed for Tesla? Or
When I've done research on that, because we've done that periodically during these calls, it's like they want to forget and sweep it under the rug, because I think they haven't really had any success beyond a couple of demonstration projects. There's certainly no widespread deployment of solar shingles. So
the article I found said that only a handful of their version 3 shingles have been installed.
yeah, and when you find out, it's usually people only within a few miles of their manufacturing facility out there in California.
They're almost like test sites.
Yeah, I'm not a big fan of solar shingles, largely because the primary thing that they're looking to solve is aesthetics, and there are better ways of dealing with aesthetics. Plus you've got cable management issues, you've got replacement of damaged solar shingles, so it's not like as easy as just unbolting the panel. You got to tear stuff up. You've got to put up dummy shingles. With the Tesla system, I would say 30% or more of the roof is going to be non-functioning shingles that are designed to look like the Tesla solar shingles. The odd shaped ones, the ones in the dormers, the ones in shadow, all of those things. So the cost, all of that just to deal with aesthetics seems like you can do better. And these companies, Suntegra, theirs, they were saying you attach directly to the decking without any racking. So I would think heat buildup, heat dissipation would be an issue.
Yeah.
So how are you dealing with that? Once again, things fail. So do you have to rip up your whole roof? Now you can't just hire a roofer. You got to hire a roofer who understands the solar. So that's going to add cost. I don't like it. I don't like it.
I agree with your skepticism.
All right, anybody else have anything for the good of the group before we call it a day? All right, well, we'll see you all next week. All right, take care. Oh, and remember, you can get a half an hour continuing education. Go into the solarpvtraining.com site if you're ETA certified. Pull it up, and you don't even have to watch the video again. You can just say mark complete, and it'll generate a certificate for you. So,
Oh, good.
all right, take care.
Bye.
Bye-bye.